Destructive tests are really very important in process industry. There are so many type of destructive tests. The main agenda here is to confirm the mechanical requirements of pipe as per the material standards, applicable material standard for that particular system. Okay, in basically what we do in any of the destructive tests, we take a sample from a pipe which is cut from the cut to perform the tests, and we generally list out all the testing outputs for that particular test piece. So if you look at, there are various destructive tests. For example, tensile test. The main agenda of tensile stress is to check the yield and ultimate strength, tensile strength of material. Okay, then there is a bend test. Bend test is again used to check the integrity of weld joints. Flattening test, it is again one of the destructive tests which is used to check the plastic deformation in the pipe. Impact test is generally, you must be aware of this Charpai V notch test, which is used to check the ability of material to withstand under low temperature conditions. Okay, so this is main agenda here. Then creep test is another destructive test which is used to check the long-term effect of temperature under constant load. Okay, so these are various tests which are performed to check various mechanical properties under different scenarios. So let us look into details of each and every test so that we can understand, we can visualize the basics behind each and every test. Tensile test, as we've discussed, this kind of tests are used to identify the yield strength and ultimate tensile strength of a particular material with respect to any material standard. Right. So what is happening here? We are stretching or compressing a specimen here. Okay, and with respect to increase in loads, stress and elongation with respect to this stretching, this kind of curve will always be there. Okay, up to certain point this material will keep on coming back to its original position, that is called elastic limit. At some point of time it will start showing some permanent deformation. Again, up to certain point it will keep on elongating. This kind of thing will be there, and after certain limit this will break. Okay, so this kind of testing is done. Mm, this is one of the destructive tests which is performed based on few ASTM standards, E8, A370, B557, and IS and British standards are there. So these kind of things are standardized and listed out in these standards so that we can identify the nature of material, of a particular material with respect to yield and ultimate strength. Bend test is one of the destructive testing. It is very simple and inexpensive qualitative test that can be used to evaluate both the ductility and soundness of a particular material. Right. As we have discussed, these tests are generally used for identify the weld defects. These are having the advantages of simplicity for both the test piece as well as equipment. Okay, this is general procedure. There is no expensive test equipment which is required to perform this test. Again, the test specimens are easily prepared. This can be performed on shop floor as a quality control test, right? So that we can ensure the consistency in production. Then again, the bend test uses a coupon that is bent in 3-point bending to specified angle, right? 3.1, 2 and 3. 3-point bending is there so that we can uh, test this pipe material at some specified angle. The outside of any bend is extensively plastically deformed so that we can easily check the defects. For example, the embrittlement of the material, it can be revealed easily by the premature failure of the coupon. Okay, so this is the basic principle behind performing this bend test. Again, there are few ASTM, ASME and British standards which are generally used to perform these tests. All these requirements have been listed out in these standards. Particular project, whichever standard is referred, those guidelines we have to refer and implement. Flattening test is one of the destructive testing which is generally used to evaluate the ability of any particular metallic tube of a circular cross section to undergo plastic deformation. Right? We press it and we can check the deformation. It is used to test the ultimate plastic deformation ability of a seamless pipe. Okay, under given conditions, we have to check the ability of a particular material up to what level this can go for plastic deformation. Okay, the basic procedure in this testing is the flattening test consists of flattening our test piece of specified length cut from a tube in a perpendicular direction. So it is very, if you look at this picture, we are having a particular piece of pipe which is pressed in a perpendicular direction. Again, there are so many applicable standards, right? European standards are there, ASTM standards are there, which defines the basic guidelines, basic requirements to perform these basic benchmarking, so that we can identify the test results and we can compare with the mentioned criteria. Impact test is a very popular destructive test which is generally used to identify the amount of energy absorbed by a material during fracture. Okay, if you look at this picture, this is a specimen here which will be hit by a pendulum, right? So we can measure the energy here, how much energy it has absorbed before it is getting a fracture. So basically what is happening, we do this, we utilize this type of testing to check the energy absorbed by a particular material at a very low temperature, right? If you look at the Titanic scenario, this was one of the classic case of impact testing. The ship was hit by a piece of ice and the crack was there. So this is what we are utilizing here. Both involve striking a standard specimen with a controlled weight pendulum traveling at a set speed. So we can calculate the amount of energy which is absorbed by that particular piece at that particular temperature. This identifies the notch toughness of test material. Okay, so this is something we are doing to identify the strength of material at low temperatures mostly. Creep test is again one of the destructive tests which is performed in the process industry to determine the amount of deformation a particular material experience over time when it is under a continuous tensile or compressive load at a constant temperature, right? So this curve, if you see, this indicates the behavior of a material. This is a time and this is a strain. So we are talking about a continuous tensile load at a particular temperature, right? So this is the deformation. It determines the amount of deformation. It is increasing with increase in time, right? This is the time, this is strain. With respect to time, as the time passes, when a particular material is at a continuous tensile or compressive load at a particular temperature for a very long time, this will be kind of behavior inside the material. So these creep tests has long been used to evaluate the sustainability of plastic materials for load carrying products, okay, especially such as pressurized pipes. Okay, there are few standards which talk about all the benchmarking guidelines requirements to perform, to check, to identify these kind of deformation. For example, ISO 9080, ASTM 2837. These are standards. These are the standards which are used to determine long-term hydrostatic strength of plastic pipe, okay, or the maximum allowable stress for specified material. So these are the standards which helps to identify this kind of behavior, especially for pipes, plastic pipes. Several different types of creep tests are available to assess the high temperature deformation of material. Typical examples are tensile creep, compressive creep, flexure creep, then indentation creep. So these kind of creeps we generally identify. These kind of creep behaviors are generally identified in during these kind of tests. So in this section where we are discussing the pipe inspection, testing and marking, we discussed about the destructive testing, the basics behind these tests, so that we can understand what is happening when we are performing these kind of tests. We discussed about tensile strength test, bend test, flattening test, impact test and creep test. So this was all about this section. See you in the next part.